While we're talking about cathodic protection of structures, one of the most common ways things are done in long distances and large structures is impressed current. Impressed current cathodic protection particularly relates to pipelines, which are buried underground, but you don't want them to corrode. Also works for ships and structures. In it, let's have a look at the picture. We've just got a DC power source that works at around about 0.8 volts. The positive side is connected to an anode that's buried in the ground that slowly corrodes or slowly soaks up electrons. Sometimes they're platinum, which happens to be twice as expensive as gold. Usually there's steel, scrap steel, but that corrodes so quickly you've got to change it yearly. Baked graphite, which conducts electricity, silicon cast iron. There's a range of materials. You don't need to know them. You need to know there's something buried in the ground. That fill around it is connected to the pipeline and it's conductive. It's not like you tip the soil back in. You put in coke breeze, which is essentially conductive carbon. Bentonite, which is what they use in swimming pool filters. One of the expanding clays that traps water to make sure that things stay conductive. Sodium sulfate, corrosive but conductive. And the impressed current is basically corroding this bit of, or this anode, and it keeps on just pumping electrons into the pipeline. Obviously the joints in the pipeline, you've got to have an electrical connection across the joint so the electricity continue. Now, if the iron tries to dissolve here off the pipeline, the electrons immediately push it back on. It's got lots of free electrons floating into the pipe, so that means it cannot dissolve. If it can't dissolve, then it doesn't corrode. If it doesn't corrode, then happy days, your pipeline stays safe. Incredibly important, especially if it's a gas pipeline that's buried underground, from South Australia to the East Coast. This is how it's protected, cathodic protection. Obviously, when that's connected into the pipeline, like so, there's your DC power source, your anode and the spacing. If you just bury a steel pipeline without any coating on the surface, you need to have these stations every 200 to 400 metres apart. If, however, you coat this pipeline in plastic to minimise the amount of corrodants that are coming into the pipe, then if you've only got a few power sources or a few leaks, and the only time is when you get a pinhole leak in the coating you need to bother about cathodically protecting it, you can go 2 kilometres to 10 kilometres between these power sources. They're obviously not cheap to run, so you would rather not have them every 200 metres, you'd rather have them every 2 kilometres to 10 kilometres. But impressed current cathodic protection is commonly used for structures. That's how it works. You are feeding electrons into what you're trying to avoid corroding, and then that basically, by imposing it as negative, you are making it into a cathode which does not corrode.